Hi, this video is going to focus on identifying the vertex of a quadratic function in factored form. Okay, for this unit, this is our learning target 2C. All right, and the reason why it's 2C is because we have already talked about identifying the vertex of a quadratic in standard form and vertex form. Okay, so now what we are going to do is really a little bit of algebra, all right, to get us into a form that we already know. Now, recognizing factored form is pretty easy because we're going to have two separate factors, and I've just denoted those as x minus m and y, or x minus n in this case, multiplied together. All right, so now what we're going to do is once we recognize and see we have two, okay, two terms multiplied together, we are going to use our knowledge of multiplying polynomials to change it from factor form into standard form. And the reason we're going to do this is because we already know how to find the factor, or excuse me, the vertex of a quadratic in standard form. So really we're going to do a little bit of algebra, get into a form we already know, and then we can use all the things that we've discussed in class about finding the vertex, all right, of a quadratic in standard form. All right, now I'm not going to go through all of this, just this here in case you need to write it down again. We did go through all these in class, but just remember that once it's in standard form, all right, we're looking for two things. One is an x value and a y value. To find our x value, we're going to use the formula that we discussed in class, negative b over 2a. And once we have that value, we're then going to plug it back into, all right, our function to find the corresponding y value. Okay, well, let's look at an example and see how we would do this. All right, so now, all right, so we want to find the vertex, and then we're going to describe the vertex as a max or min. So when we look at this, all right, we see we have this binomial times this binomial. So we're going to use what we know about multiplying polynomials. So I'm going to do x times x, which is x squared, x times negative 2, so that's negative 2x, negative 4 times x, which is negative 4x, and then negative 4 times negative 2, which is positive 8. So what we now know, oops, let me go back and erase that. Got a little bit of a hurry there, so that's not a y squared. That is just a y, and that's going to equal to x squared. And once again, we have like terms here in the middle, so we're going to combine those, minus 6x plus 8. So by distributing and combining like terms, all right, we are now in standard form. And then what we know from standard form is that I can find the x-coordinate of my vertex using the formula, the opposite of b divided by 2a. So now remember, b is always the number, okay, the coefficient in front of x. So in this case, b is negative 6. So the opposite of b would make that a positive 6. And then I'm going to have 2 times a. And then a, all right, is always the coefficient of our x squared term. And in this case, it is going to be 1. So I end up with 6 divided by 2, which is 3. All right, so we know the x-coordinate of our vertex is 3. Okay, so now we have to find the corresponding y value. So to do that, I can go back and plug it in. Now, I can either go back to our original function, all right, from the very beginning, or I can go into this function. You will get the same y value, all right, in either, okay, equation. This is also a great way of self-checking, because if you don't get the same y value in both of these once you plug it in, all right, you did something incorrectly when you, all right, converted to standard form. All right, I'm just going to use the equation in blue to start with. So I'm going to plug in. I've got 3 squared minus 6 times 3 plus 8. So that would give us 9 minus 18 plus 8. All right, and then 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. All right, now what I'm going to do now is just really quickly show you. You would get the same thing up here. So if I plugged in, I would have 3 minus 4 and 3 minus 2. And so I would end up with 3 minus 4 is negative 1, 3 minus 2 is 1, and then I would get negative 1. So we do in fact know that, all right, the y-coordinate of our vertex is negative 1. All right, so now we discussed how to do this in class. Now what we want to do is describe the vertex as a max or a min. So what we talked about in class is we need to know whether it opens up or down. So I'm going to go back to my a value, which was 1. All right, since a is equal to 1 and greater than 0, we know we have a quadratic that opens up. Because of that, we know our vertex is a minimal value. So, okay, the minimum value is negative 1 at x equals 3. So remember, we're going to write that out as a complete sentence, all right, each and every time. All right, well, let's take another look, all right, at another example here, and then I'll give you some to do on your own. All right, so looking at this guy, all right, once again, we recognize that it's in factored form. So what we're going to do is now distribute. All right, so I'm going to do 2x times x, 2x squared. 2x times negative 5, negative 10x. All right, I'm going to come back with my second distribution with our 6. So 6 times x is 6x. And then 6 times negative 5 is negative 30. We're going to combine our two like terms here. We have two linear terms. So 2x squared, negative 10x plus 6x is negative 4x. And then I have my minus 30 here. So now we are in, all right, our standard form. So now we can jump right to what we've discussed in class, the opposite of b divided by 2a. So I can come up here and I know b is always the coefficient of my x term, so that's b. So it's negative 4, so the opposite of negative 4 is going to be positive 4 for our numerator. And I'm going to have 2 times a, and then a is always the coefficient of the x squared term. So that's 2, so I get 4 divided by 4, which is 1. So we have half of our vertex. All right, so once again, we can just take this value, go back and plug it in. All right, so I'm going to do that here, and I'm just going to use that our standard form here. So 2 times 1 squared minus 4 times 1 minus 30. So y would equal to 2 times 1 minus 4 minus 30. Let me scroll down a little bit here. All right, so then this would be y equals 2 minus 4 minus 30, all right, which would be negative 32. All right, there we go. All right, so that's the other half. Now, when we go to describe the vertex, once again, we need to know if it opens up or down. So we know our a value is 2. That's greater than 0. All right, so we were going to have a quadratic that opens up. So once again, we can see that this is the bottom of the valley. So that's going to be a minimum. All right, so then the minimum value is negative 32 at x equals 1. All right, and once again, we're kind of writing like this to get in a good habit, because once we start getting into application questions, all right, it's going to make it much easier for us to talk about our max and mins, all right, when we get into those types of questions. All right, so I have some problems for you to do now. All right, so let's look at the next example. So what I would like you to do is go ahead and complete this problem, find the vertex, describe it as a max or min. All right, so go ahead and pause the video, and then when you're finished, turn it on and compare your work to my work. Okay, let's look at how you should have done the problem. All right, so I am going to distribute. So I get negative 6x squared plus 3x plus 18x minus 9. Combining like terms, I get negative 6x squared plus 21x minus 9. All right, so once again, just distribute. 3 times negative 2x, negative 6x. 3 times 1, 3x. Negative 9 times negative 2, positive 18. Negative 9 times 1 is negative 9. All right, so now I'm in standard form. So now we're going to go to, all right, our short formula here, negative b over 2a. All right, so then I'm going to go right here. So the coefficient of x is our b term. So this is positive 21. So the opposite of b would be negative 21. Then I'm going to have 2 times a. Okay, and then a is always the coefficient of our x squared term, so that's negative 6. So notice here we don't get a very pretty number. So negative 21 divided by negative 12. Okay, so that's going to be a positive. And then, you know, you may not know that right offhand, so just come to your calculator. 21 divided by 12. All right, so 1.75 is the x-coordinate of our vertex. All right. And that happens. Not all of our vertexes are going to fall on nice, pretty integers, so negative 2, 8, or whatever. We may have some 1.75s or 3/4 or negative 1/2 and things like that. Now, even if this is a decimal, it doesn't change what we do. So once again, you're just going to go back, all right, and plug 1.75 in wherever there is an x. So 1.75 and then minus 9. Now, and I talked about this in class, that if you have a scientific calculator or you have a calculator that allows you to put this all in one screen, it's really nice because I can just go negative 9, open parentheses, and I can basically type exactly what I wrote on my calculator, and that gives me an exact answer very quickly. All right, as quick as you can type. So I hit enter here, so 9.375, so y equals 9.375. So that's the other part of my vertex. There we go. All right, describe it as a max or min. Once again, we gotta go back to our A value. In this case, A is -6, which is less than 0, so we know it opens down. All right, so then we know that the maximum value is 9.375 at x equals 1.75. There we go. Okay, let me minimize this for you, and let's look at the next example. So once again, you attempt this, and then pause the video, or pause the video and attempt this on your own, then turn it right back on and see how you did. All right, so let's see how you did on this problem. All right, so notice a little bit different here, but it's still considered factored form. We have one term times another term. All right, so still factored form, but we get to standard form a little quicker this time. So I only have two distributions, so I get -12x squared and then -24x. All right, so very quick if I just have a monomial times a binomial. And in this case, our c value is 0. All right, so I jump right into -b divided by 2a. Okay, so the coefficient of x is our b term. It's negative, so the opposite of that's going to be a +24. And then 2 times a is the coefficient of our x squared term, so -12. So 24 divided by -24 is -1, so that's half of our vertex. All right, so now we just have to go back and plug that bad boy in. So -12 times -1 squared minus 24 times -1. So y equals -12 times 1 plus 24. So -12 plus 24 would be 12. So our vertex is -112. Now we'll describe it as a max or min. We're going to go back to our a value, which is -12, and that is less than 0, so we know we're going to have a quadratic that opens down. We're definitely at the top of the hill, so we have a maximum. So the maximum value is 12 at x equals -1. There we go. All right, so one final example to see how you do. Now there's a little bit of a trick to this, not really a trick, but something that you definitely need to see in this. So go ahead and work the problem, pause the video, and let's see how you did. All right, so what I was referring to is what happens when you distribute here. So you may notice that when you distribute, all right, so 5x times 5x is 25x squared, no problem there. 5x times 4, okay, positive, whoops, not 16. Let's go back and try that again. How about a positive 20? All right, so a positive 20x. And then when I distribute here, notice what I get. I get -20x, and then I get -16. And so notice when you combine terms right here, all right, we get 25x squared. This is 0. It's gone. So I'm left with this. All right, so now we discussed this in class, and that this is one of the forms, okay, that can be considered two different forms. You can consider this as vertex form, all right, or we can consider it as standard form. And what we talked about in class is that it's just much quicker if we recognize that there is no linear term here. It's a quadratic term and a constant, which means it's vertex form. So what I should be able to do is look at this and say, oh, my vertex is 0, -16. Now, for some reason, if you don't, what you have to do is go to this, -b over 2a. And what you have to recognize here is that this is really 25x squared plus 0x minus 16. So your b value is 0. So I'm going to have 0 divided by 2 times 25, which is 0. And then when I plug that in, I'm going to get 25 times 0 squared minus 16, which is going to be 0 minus 16, which is -16. So if you don't recognize that this is vertex form, the big piece is that you have to know that your b value is 0. Okay, now once you do get that, okay, we're going to go back. Oh, a is a positive 25. Oops, let me try that again. All right, let's try it again. Here we go. A is 25, which is greater than 0, so we know we have this guy. Okay, so we know the minimum value is -16 at x equals 0. All right, my friends. So that wraps up this lesson. So you should do one of two things. Either if you have, well, never mind. I'll just say this. So come to class with your notes, any questions you may have, and then be prepared to complete worksheet unit 6-3. See you in class.